getting started. We'll start from current slide. And I'll even put on the projector. Now, if any of you have not been here in the last few days or came in after I made the announcements, there's a very important announcement right up here. They said to post it, so I made the announcement for at least once every class. If you are going to be here next fall, which I hope you will be, unless you're graduating before then. If you're going to be here next fall and have been on or are going to be on FAFSA, that's the free application for federal student assistance, okay? If you're going to do that, please do that now. Get your 2021 FAFSA done now. The reason for the push is that the school is going to a totally new operating system, okay? The people in Montgomery are requiring us to do so. Can I get your name? Say again? Fuller, got it. Latrissa, right? Okay. Good deal. All right. And when I say a totally new system, I mean totally new. The one we've had was ancient when we started using it, and we've been using it ever since the merger. It was a political boondoggle at best. And Kwame, speaking of political, I'm sorry I didn't say that, okay.
What did it do?
What's that?
I said, what did it do?
I was just talking about political boondoggle. Okay. The package we had was pretty pathetic, but the bad news is nothing that was done in the old system is going to directly transfer into the new system. So therefore, they've got to enter everything from scratch. And it's not entered the same way, completely different architecture, everything's different. So, whereas before, they could probably just do a click or two of the buttons and you would be fine, if you redid the FAFSA. Now it's not. They have to do everything from scratch to get you into the new system. So that's why they're wanting you, the existing students, get your FAFSA done now. This is for next year, 2021, okay? Get it done now so they can get you in the system, not wait until the fall when they have all the new students coming in. They've got to get in the system. And this new system is not an easy system. We've had many staff members down in Montgomery almost all week long for several weeks a month, for several months. I mean, it is not an obvious transition. It is really a pain in the neck from what I hear. Now, the bad news is I'll be retiring next year and won't have to go through it. Shucks. I was looking so much forward to that. Okay, never mind. All right. Any questions on anything we've done so far? Oh, the other announcements were today is when the Lawson State College Transfer Fair Day schools will be on this campus from 9:30 this morning until 11:30 this morning, somewhere near the cafeteria. They may be in the cafeteria or in the faculty staff dining room, in the hallways outside, maybe at the front desk area. They may be scattered anywhere along there. Please go take advantage of this. Even if you're not really close to transferring yet, get an idea of what they're looking for, what the opportunities are, what you might find from the various schools. I see at least one Alabama shirt on, and if you're interested in going there, they should be here. So probably some others of you have on some paraphernalia from other schools. Please go by and check it out. And this is the last time you'll hear an announcement from me for this REU, Research Experience for Undergraduates, because the deadline is next Monday. So by the time we meet again, it will be passed. Now there's other REUs out there, Research Experience for Undergraduates. They're fantastic programs sponsored by the National Science Foundation, very lucrative. They pay you to participate. They feed you, they house you, they do all sorts of good things provide you transportation to campus and back once, okay? So they're great programs. Look into them. This is just one. Look into the others as well. All right. Yes.
You know, yesterday that career grip
Right.
on the Best Birmingham campus.
Yeah.
It was so cluttered.
It was what?
It was cluttered. They had it right there in the middle of the hallway on the B hall.
Yeah.
It was so cluttered. It was awful.
Okay. And I'm afraid that may happen here too, because they sure can't fit everybody in the cafeteria. I don't think. Especially with the end of breakfast and beginning of lunch, that would be nuts. So I think they'll be in the faculty staff dining room, but that's still going to be cluttered. So I take it what you're saying is there were a lot of schools here. Is that right?
Yes, it's all
Okay, so go by and take advantage. Hopefully here they'll spread out more. I can't swear they will, but hopefully they will. And find your school. Check into it. Okay? All right. Any questions, either about that kind of stuff or pre-calculus algebra? All right. This is Johnson. Got it. All right. Got it. Okay, and Marina got it. Trinity, right? Okay. Now, any questions? And I think I announced this to y'all before too. Last week, I think it was, they removed all unpaid students from the roll, and so far, most of them have been put back in, but I know in one class there's at least one that hasn't been. So if you were removed from the roll, that means you probably can't access Student Suite, you probably can't access Blackboard. Find out, and if you do need to clear up some sort of payment, please do that. All right, any questions? Okay, we're in Chapter 1, Functions in the Graphs, Section 1.8, Combinations of Functions and Composite Functions. We aren't at composites yet, we're just on combinations, and we're on page 76, just above the middle of the page. Okay, any questions? Other questions? Okay. Now, we talked about adding, subtracting, multiplying and dividing functions. So the issue comes up, what will be the domain of these new functions? Excuse me. What will be the domain of these new functions? So let's say that we have f and g are functions that you're doing some arithmetic combination for those. What f has some domain, g has some domain. What would the domain of that combination be? Well, it will consist of all real numbers that are common to both the domains of f and g. Okay, now what does that mean? Let's just say that f is, the domain of that is all positive numbers, from 0 to positive infinity. Now let's say that g has a domain from -3 to +3. What would be the domain, say, of the sum or difference or product of those two functions? Any ideas? F has a domain from 0 to positive infinity. G has a domain from -3 to positive 3. What would be the domain of the sum, the difference, or the product of those two functions? Things that are common to both domains. Any ideas? F, 0 to positive infinity, so let's use a 4 here. 0 to positive infinity, g -3 to 3. What's common to those two domains? Again, 0 to 3. Perfect. 0 to 3. These up here are in G. These over here are in F. Okay? So therefore you are limited to 0 to 3. Okay? Now, what if we were dividing those two functions? F divided by G. Well, G was defined at 0, but if, okay, I don't get this confused. Even though it's defined at 0, that's fine. But what if G had a value of 0, say at 2, okay? If it is, you have to exclude that value. It would be 0 to 2 and then 2 to 3. You have to do that because you can never divide by 0, okay? So division has one other issue with the domain you have to look into beyond what's common to both. Always has to be common to both. So, here's what we got. Sum, difference, and product and quotients of functions if f and g are two functions with overlapping domains. Now, if f's domain was over here and g's domain was over here, you can't add them, you can't subtract them, you can't multiply or divide because, John's here, because they have no parts of the domain in common. But if they do have overlapping domains, that either part or all of the domains are common, then for all the actions common to both domains, the sum, difference, product, and quotients of f and g are defined just like we talked about before. The sum function, f plus g of x, the sum of two functions, the sum function of two functions is equal to the sum of those functions. The difference of two functions is equal to the difference of those functions. The product, fg, of those two functions is f of g times f of x times g of x. And the quotient function is the quotient of the two functions, f of x divided by g of x, as long as g of x is not 0. You have to eliminate any elements in x that would make that g 0. Okay? Does that make sense? Let's actually do something. Here is a function, two functions, f, can't get my pen out, there it is. F of x is 2x plus 1. Got to get my pen set up. Okay. G of x is x squared plus 2x minus 1. What is the sum function? What is f plus g of x? By definition that we just had up there, what is the sum of two functions? What is the sum function of two functions? F of x plus g of x, okay? And we know what each of those are. What's f of x? 2x plus 1. And what's g of x? X squared plus 2x minus 1, okay? Now, pause for a moment here. If you prefer just to highlight it for your own mind, you can put f in parentheses here plus g in parentheses here. But as long as it's a plus, the parentheses are doing you no good. The first thing you're going to do is get rid of the parentheses. So I just skip that step and don't even put them. The book usually does put parentheses. If that helps you see it, go for it. So what are we going to do with those two functions? Combine like terms. And what do you get? X squared plus 4x. That's it. Okay? And for some reason, the computer just decided to go nuts. So there's your f plus g of x. Then evaluate that sum when x is equal to 3. So we're going to do f plus g of 3. And what would that be? Wait just a second. Say again. Plug in the 3 and what you get? 9 plus 12 equal 21. Perfect. Does everybody see that? You plug in the 3 for x here. 3 squared is 9. Plug in the 3 here. 4 times 3 is 12. Plus sign in between, 21. Now, remember this up here? What you could do, if you find it easier, it's up to you, you can plug in f of 3 here. What's f of 3? Say again? 7. What's g of 3? 9 plus 6. 2 minus 1 is 14, is that right? 7 plus 14 is 21. So you can do it either way. You can either plug and chug or chug and plug. Either way. You can plug it in early. You can combine the functions and plug it in there. What's that? How did I get 12? Plug 3 in for x. And 3 squared is 9 plus 4 times 3. Yeah. You plug in the 3 for every x in the sum function. Okay? Good question. Any others? All right. That was example 1. Let's see how they do it. I'm going to erase what I did. Can I erase yet? Y'all still writing? Everybody got it? Okay. All right, let's see how they do it. The sum of f and g, f plus g of x, is simply f of x plus g of x, exactly like we said. And then they did, like I said, they put f of x in parentheses plus g of x in parentheses, and then the next step is to remove the parentheses. So what's the point, okay? But they removed everything and combined them all at once and got x squared plus 4x without showing exactly the steps. But that's okay. They're the book. They can do that. Now they're going to evaluate when x is equal to 3. So we plug in 3 for x everywhere you see an x. So that's 3 squared plus 4 times 3. And that gives you 9 plus 12, 21. Okay. Now, they're skipping example 2, example 3, example 4. Okay, so let's us go back and do those. Okay. Example 2 uses the same two functions, but this time they're going to do f minus g of x. So what would you do? What is f minus g of x? By definition, help me. F of x minus g of x. Right. Okay. Just put in f of x, 2x plus 1. You don't have to put it in parentheses. If it helps you see it, put it in parentheses. But after a minus sign, you'd better put it in parentheses. Okay? So the g will go in parentheses, x squared plus 2x minus 1. And if for no other reason to put them in parentheses to keep from making that error, then put them in parentheses always. When it's preceded by a plus, you just remove parentheses. When it's preceded by a minus sign, you have to change the sign of every term in those parentheses. So what's your next step? 2x plus 1 minus x squared minus 2x plus 1. Excellent. And what does that give us? Negative x squared plus 2, because the 2x minus 2x added to 0. Okay? Now the next part says evaluate the difference when x is equal to 2. So what we're looking at now is f minus g of 2. Not 3, but 2. What would that be? Say again? Okay, yeah, substitute in 2. Is that what you said? Negative 2 squared plus 2. All right. Name, please. Huh? Graham, got it. Great, right. Okay. Just got to find you. There you are. All right, good deal. Does anyone else come in while I wasn't looking? You haven't heard me acknowledge your presence. Okay. All right. So now, how do you do that first step there? This one right here. What you do first. Say again? Yeah, you do the 2 squared first. Always do the exponent before you negate. So that will be minus 4 plus 2 is negative 2. Does everybody see that? That's another tricky point. It's not negative 2 squared because the negative is outside. The x is the 2. That's what you square. Then you negate it. Please excuse my dear Aunt Sally. I don't know what she did, but please excuse her. Excuse this exponent. Aunt Sally is adding and subtracting. Treat the negative sign as if it's a subtraction. So it's minus 4 plus 2. That would be negative 2. Does everybody see that? And by the way, after every one of these examples is a checkpoint. Please try to do the checkpoints as soon as you can after class. If you have another class or 2 classes or 3, as soon as you can get some free time, try to do the checkpoints. If you can't get the answers, because the checkpoint answers are in the back, then you can go to larsonprecalculus.com and see those checkpoints worked out. Audio video solution. Okay. Any questions on example 2? All right. Okay, to erase this one doesn't have it. I'll let you finish writing. Is this making sense? Okay, everybody got it? All right. Let's clear that screen and do example 3. Oh, we'll come up with different f functions this time. Okay? This time f of x is equal to x squared, and g of x is equal to x minus 3. And what they want you to find is fg of x, the product function of those 2 functions. So what would that be? What's the definition of the product function? That's f of x times g of x. Pretty easy stuff, isn't it? And what would that be then? X squared times x minus 3. And then go to town with that, and what do we have? X cubed minus 3x squared. Perfect. Then the next thing they wanted us to do is evaluate the product when x is equal to 4. So we're looking for fx of 4. And what would that be? 4 cubed minus 3 times 4 squared. Perfect. Okay, my writing isn't too perfect. All right. And what in the world is 4 cubed? 64 minus 3 times, always do the exponent first, 16. And 64, what's 3 times 16? 48. And 64 minus 48 is 16. Perfect. Okay? The quotient function is 16. I forgot to do this on the last one, but let's do it, just for funsies. Okay? Let's plug in 4 up here. What's 4 squared? 16. And what's 4 minus 1? 4 minus 3? 1. 16 times 1? 16. You could do it either way. This one's actually easier to do it the first one. Plug in the x before you multiply. Okay? Not always that way, but this time it was. Say again? Okay. Any questions on this? Anything that's a little cloudy, uncertain, making sense? Everybody got it? All right. We'll clear this one. And example 4. Finding the quotients of two functions. Find f divided by g and g divided by x for these two functions. Oh, and here's something else I had forgotten to do. Okay? Let's go back and look at example 1, which is right here. What's the domain of those functions? F of x, the one that's up there? All real numbers. It's a polynomial, right? How about g of x? All real numbers, so the domain of the sum function will be all real numbers. Okay? When you look at example 2, polynomial, polynomial, same two polynomials. The difference function, all real numbers. When you look at example 3, a polynomial, polynomial, the product function, all real numbers. Okay? But when we do example 4, they really throw everything in the pot here. Here's your f of x is equal to the square root of x. Oh boy. G of x is equal to the square root of 4 minus x squared. Ooh, okay. Then, it says here, find first f divided by g of x. What is that? That would be f of x divided by g of x. Okay? And what would that be? Four minus x squared. Okay. Now, you can leave it like that. That's perfectly legitimate to leave it like that. There's nothing much you can do with that. If you wanted to, since the square root's numerator and the denominator, you could, but you don't have to, write it as the square root of x over 4 minus x squared. That doesn't help anything, but you could write it that way. It's perfectly fine. Okay? Either way is fine. Now, if we were doing WebAssign, now, have y'all done WebAssign before? And you loved it, right? Yeah, you really appreciate it, okay. I don't really care for it because WebAssign would only have one correct answer. And it would tell you the other answer was wrong, even though it was perfectly correct. Because, see, it's a computer program. And believe it or not, computers are stupid, okay? They can only acknowledge what you program it to do. And if you programmed it, and they did, to only recognize one correct answer, they're going to say every other answer is wrong. That's a problem, okay? Now, artificial intelligence is supposed to maybe someday overcome that. Right now, that intelligence is mostly still artificial. I don't know. I didn't say that, did I? They can do a lot of things, but I don't. WebAssign is not to that point yet. Okay, so that's why I don't really do too much with it. Okay. Now, let's go on and do the second part, which is g of f of x. G divided by f of x, okay? And how is that defined? G of x divided by f of x, okay? And what would that yield? The square root of 4 minus x squared of the square root of x. All right. Minuet? Yeah. All right. Now, the other one, I said there really is no advantage to put it all under the square root. This one, there's a little bit of an advantage. Because what would that be? The square root of 4 minus x squared over x. Now that's no better, but you can do this. Again, both of those answers are correct, but you could also do this. The square root of 4 over x minus x. That's a little bit simpler. Because you see, when you have a binomial over a monomial, you can split that to be 4 over x minus x squared over x. And 4 over x is this, and x squared over x is just x, with a minus in between. Now, no advantage, yes? Okay? Don't let this confuse you. I'm just showing you different ways you can express an answer. Okay? Okay. Because if you didn't have the square root there, and you had 4 minus x squared over x, right? That's the same as 4 over x minus x squared over x, right? This is how you split up subtraction of fractions, right? And 4 over x is that, but x will go into x squared x times, so this gives you 4 over x minus x, okay? And then this is all in the square root, so that's why I put the square root over it. It's no better answer than either one of these two. But I can't read WebAssign's mind, so I can't tell you which one they were going to choose. They may go with this one, or that one, or that one, okay? But they're all 3 correct answers. And they all give credit if you chose any of those. That's why I don't make WebAssign assignments, because they sometimes will mark answers wrong that are perfectly right. And that just drives me nuts. It makes students frustrated, and it makes me pretty frustrated too, for them to tell you got something wrong when you had it perfectly right. Okay, now, let me get rid of this. Can I erase this middle part here? Okay. Does that answer your question? Okay. Now, the second part of this one wasn't to evaluate it at some point. It was to determine the domains of these functions. The first 3 examples were domains for every function was all real numbers, so the sums, the difference, and the products were all real numbers. This one, however, is not. What is the domain of f? What would x have to be for f? Yeah, all non-negative numbers. X has to be greater than or equal to 0. Now, to me, that's the shortest way to give the answer, and it's fine. You could put it in set notation, the set of all x's such that x is that, or you could do it in interval notation, which would be, tell me what it would be in interval notation. Okay, 0 would be the first number. What precedes the 0? Say again? The bracket, okay? Because you're including 0. You see that? Parentheses would say you were excluding 0. But because the 0 is included, and then it goes how far? Positive infinity. And that is always followed or preceded by a parentheses. Okay? How about G? Woo, G's going to take a little more effort. What does this tell you? What's inside the radical has to be, no, positive. I pointed it the wrong way. Okay. That says that 4 minus x squared has to be greater than or equal to 0, right? But that's a polynomial. We got to figure out what makes that polynomial greater than or equal to 0. Now, can anyone look at it and tell? Or might you need to do just a little bit of work? Oh, that sounds bad, doesn't it? We could. What's the F word? Huh? Ooh. Factor. Factor that. Will that factor? Say again? Yeah, leave the 0 alone, the left-hand side, this part here. Will that factor? Okay, 2 minus x, is that what I heard? Say yes. Times. Help me. to plus x. Okay. That product has to be greater than or equal to 0, right? Okay. Now we have another issue on our hands. Okay. That issue, if you have two numbers and they've got to be non-negative, what does that tell you about those two numbers? They have to have the same sign. If you're multiplying two numbers together, two positives will give you a positive, or two negatives will give you a positive. But a positive and a negative will give you a negative, right? A negative and a positive will give you a negative, right? So, either both of these have to be positive, or both of them have to be negative. So, we've got some more work to do, okay? So, how do we say that in math speak? 2 minus x, if it's positive, it has to be greater than or equal to 0, and, not or, 2 plus x has to be greater than or equal to 0. So let's solve both of those. I think I would add the x to both sides. Would that be all right? Is that legal in most states? Okay. So the x's go out here, so you have 2 is greater than or equal to x. Right? Yay or nay? Okay. On this one, let's subtract 2 from both sides. This goes away, and that gives you x is greater than or equal to negative 2. All right. Now, I'm used to doing this, but I sort of like to go back and actually put it on a number line. So let's put those two on a number line. Okay, here's my number line. There's 0, 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5, you know, whatever. Where would be 2 is greater than or equal to x? Or, if you want to turn this around, make this x is less than or equal to 2. Isn't that saying the same thing? You just flip the sign. So x is less than or equal to 2. There's 2, but it can be equal to, so I'm going to color in that 2. Which way do we go to be less than or equal to 2? Is this making any sense? For x to be less than or equal to 2, which way do you go? This way, okay? So that would be all the values down this way. All those values are less than or equal to 2. But it also has to be, the and in there, that x is greater than or equal to negative 2. Well, there's negative 2, and it can be equal to it, but now you have to be greater than or equal to that way, right? So this would be all numbers this way. Well, what do those have in common? From negative 2 to positive 2. There's your domain, right? All this to get your domain, okay, of that one function. We already have this domain, but now we're getting it for g. But we're not through yet, are we? Because these could both be negative. So that means that either, I'm running out of room here, 2 minus x is less than or equal to 0, and 2 minus plus x, if I could write, is less than or equal to 0. So either both have to be positive or both have to be negative, okay? Well, we're going to do the same thing we did to the others, and this gave us 2 is less than or equal to x, and this gives us that subtracting 2 from both sides gives us that x is less than or equal to minus 2. All right, let's take this same number line here. I'm going to erase most of the mess that I did to it. I hope I can get most of it out of there. Oops, I erased too much, didn't I? How did that get up there? Okay. All right. There was our number line. Now let's do this one. Okay, excuse me. Are there questions? Other questions? Okay. We can rearrange this and say x is greater than or equal to 2. That's the same thing as 2 is less than or equal to x, right? Well, what's that? That's all the values on this side of 2, right? Excuse me. Have you got questions?
No, sir.
Okay. And this one is x is less than or equal to minus 2. Well, that would be these down here. And they both got to be true at the same time. Can a number be over here and over here at the same time? No way. So this one's completely out. The possibility of 2 negatives, that's out of the picture. But the one we had before, whoa, and I forgot to write it down, that's good. And that one was negative 2 is less than or equal to x is less than or equal to 2. There, excuse me, is there a question? Okay, this is the domain of G. You're in between negative 2 and 2. You can write that in interval notation of minus 2 to 2, but brackets on both of them because the equality stands. Okay? Now, that gave you a domain of F. This gave you the domain of G. What do these two have in common? This is all numbers greater than or equal to 0. This is all numbers between minus 2 and 2. Again, the number line may be helpful here. Okay? So I'll erase what I've got on the number line here, if I can. Okay? Now, I didn't erase it correctly, but I'll get most of it. Okay? Erase too much. All right. Let me erase some more. Okay. It sort of stinks. Okay, let me draw my number line over again. Whoops. Yeah. All right. There's my number line. The domain of F is from 0 to, and including 0, all the way to positive infinity. Every value here. The domain of G, give me a different color so we can do G in a different color. Give me a color. Red, okay? So the domain of G is between minus 2 and 2. Okay, that's in here. What's common to both of those? What's common to F, which is all these, G, which is all these? What's common to those two? 0 to 2. You're absolutely right. So the part of the domain of F and G that are common to both is 0 to 2. Okay. However, whoa, we're never going to finish this problem, are we? We will. I have confidence we will. Okay? Here's the other issue. I'm going to change my pen back to black. Okay? Here's the other issue. For the F divided by G, notice what we have in the denominator. Whoops, I'm in the wrong one. Here we go. In the denominator here, we have this. Excuse me. Is there a question? Okay. Excuse me. Now, are any values you have to eliminate here? Now, we've already done the work of this, that this denominator is, we did it for the square root. What we didn't do was it being in the denominator. What can the denominator never be? 0. So this is telling you that 4 minus x squared cannot equal to 0. Okay, so it's no longer greater than or equal to 0. It is not equal to 0. Okay? Whoops. Okay. 4 minus x squared cannot be equal to 0. Well, that tells you that either 2 minus x is not equal to 0 and 2 plus x is not equal to 0. Well, 2 minus x not equal to 0. Again, add x to both sides, you get 2 is not equal to x. And over here, subtract 2 from both sides, and you get x is not equal to negative 2. Okay? So in this case, we already eliminated the minus 2, so that's out of the picture. But in this case, you cannot include 2, because 2 cannot equal 0, right here. I mean, x cannot equal 2, okay? Because that would give you 0 in the denominator. So in the first case here, your domain here, and I think I'll go back and put this in red, okay? Okay? This implies the domain of, come on, show up. Well, it's not showing up. My pen's not writing very well. The domain of f divided by g would then be from 0 to 2, not counting the 2, because the 2 would make that denominator 0. Okay? But when we do the other one, domain of g divided by f, okay, now when we do this one, what can't be 0? This is like g divided by f. What can't be 0? Say again? The x can't be 0. So this time you have to eliminate the left-hand end. So the domain here would be open parentheses 0 to 2. And that one you box in. You can have a 2 now because that puts you 0 in the numerator. That's fine, no problem with it. But you can't have the 2 at the 0 in the denominator. So, goodness gracious, what a problem. Just to find the domain of any function with square roots in it takes a little bit of effort. When you have a polynomial, that takes even more effort. And then when you're dividing, you have to then eliminate the zeros in the denominator as well as negatives in the square root. So, the book goes through that as well. They sort of do it without telling you very much of how they did it, and they just gave you those two answers. Okay? They got it right, but they just didn't do a good job of explaining why. Okay? So, just so you'll know, this is the domain of G here. Okay? All right. And every one of these examples is followed by a checkpoint. Please do those checkpoints. They will help you make it yours. All right. Any questions before I delete all that mess? Any questions? Okay. Now we move to the new stuff. Well, that was some of that, especially the domain stuff was sort of new. But adding, subtracting, multiplying, and dividing is not all that new. But the composition of functions, that sort of is new. Okay? Another way of combining two functions is to form the composition of one with the other. Okay? For instance, if f of x is a squaring function, whatever you have on the inside, you square it. Okay? G, on the other hand, is an addition function. You just add 1 to it. G of x is x plus 1. Whatever you have on the inside, you add 1 to it, and that gives you your new value. Now, the composition of f with g, okay? You have to pay attention to the order here. The composition of f with g here's how you define it. It's f, the f function, operating on the g function, f of g of x, okay? Now the g of x is x plus 1, so you put that in instead of g of x here, and then you do the f, which is the squaring function of this thing, which means you take this thing and square it. Does that make sense? Okay? You just do what the functions tell you to do. This is the composition denoted as f of f composed with g. It's read f composed with g. But I just called it f of g, which is exactly what you're doing here. Or you could call it fog, and it'd be really foggy, but that's, hopefully it won't get foggy any longer. Okay? So, that is f composed with g, which is f of g of x. That makes sense so far? Do what it tells you to. Okay? Can I erase? Move to the next slide? Okay, 1 second. I'll give you 10 seconds. No, I'm just kidding. Anyone need more time? Have as much as you want. Okay, everybody got it? Okay. Here's a definition of the composition of two functions. Composition function f with the function g. The order matters here, okay? F composed with g of x is, this is the definition, f of, I think of that as an of g of x, okay? Just read it that way and it works. The domain of this f of g, f composed with g, is a set of all the x's in the domain of g, such that when you get to the range of g, the values, the y values for g, they are in the domain of f. Because once you evaluate this function, then it becomes the input for that. So all the x's in the domain of g, such that the x's in the values of the range of g becomes the domain of f. All right. Now here's sort of the mapping diagram that supposedly illustrates this. Sometimes I find this a little confusing. But here is the domain of g. The g function operates here, okay? And when you take g of x, you get the range of g over here, okay? So you're mapping from here to there, okay? That's what the g function does. Then the f function takes these values in the range of g and maps them onto the range of f, which goes here. The composition function starts with this and goes straight to that, okay? The composition function sort of skips the g because it's using the g in the middle part, okay? So, let's do something. This is example 5 on page 78, about the middle of the page. This one's also at larsonprecalculus.com. If you go there, you'll see an interactive version of this example, or this type of example. So here's your f. Let me go back to black here. Okay, there's your f, and there's your g. So you tell me what f composed with g is. What's the definition of that? F of g of x. And what do you plug in first? The g, the innermost function. So leave f alone for now and plug in what g is. Well, g is what? 4 minus x squared. Okay? Now we pull out the f function and start operating with it. The f function says whatever is inside this parentheses, you take that and add 2 to it. So what's inside the parentheses here? 4 minus x squared and add 2 to it. There you've operated on f, but you operated on the g function. And what does this give us? Say again? Negative x squared plus 6 or 6 plus x squared. Either one you want to do it. That's sort of an ugly x, isn't it? Make that a little neater. Okay. Negative x squared plus 6 or 6 minus x squared. Either one would do. On the other hand, what would g of f be? It's what? It's g of f of x. That's it. So which one do you plug in first now? The f function, and that's the x plus 2. Okay? Now g takes whatever's inside here, begins with 4, and subtracts the square of that. So what would that be? Ooh. Okay. Okay, I'm trying to find it now. 4 minus, what did you say? X plus 2 in parentheses squared. Now notice you do the exponent first. So this would be 4 minus, can you square that? What do you get? X squared plus 4x, excellent. Not x, plus 4. Plus 4, okay? Now you do your subtraction or distribute the minus sign, whatever you want to call it. That would be. Say that one more time. Okay. All right. Yes, you do. You just distribute the minus sign across every term inside.
So it basically be -1.
It can be -1. I thought that may be what you were saying. Yeah. Yeah. Okay. So that would be, well, no, start with the 4. 4 minus, right? Minus 4x minus 4. And combine like terms there, and what do you get? What do you get when you combine like terms? See, 4 minus 4 adds a 0. That leaves you minus x squared minus 4x. Now, note something. F composed with g is not always the same as g composed with x. F, okay? In other words, the composition is not necessarily commutative. You can't go either way. You have to one way or the other. This gives you this answer, that gives you that answer, totally different answers. Okay? Now, let's take our answer here and evaluate it at -2. So, g composed with f, that's this one, is equal to, how would I do that? Plug the -2 in there. What would that give us? Negative of -2 squared. Next. Minus 4 times -2. Oh, how did you guess that? Okay. All right. So what would that be? I'm going to erase all my marks here. Okay. Just a moment here. Okay. Now, warning, this minus sign is here. Now square the -2, and what does that give you? Really? -2 times -2 is? +4. And then -4 times -2 is? plus 8. And that gives us 4. Feel like a dentist here pulling teeth. Okay. Now, let me just point out something out to you. What if you had done it this way? G composed with F of negative 2, by definition, that's G of F of negative 2. Okay? Well, this is G of, when you put negative 2 in for X, what do you get? Up here. Negative 2 in for X. Put a negative 2 in for X. Here's your F of X. Okay, I'll do it down here. That would be negative 2 plus 2, right? Your F function takes whatever's inside the parentheses and adds 2 to it. So what's in the parentheses is negative 2 plus 2, and that would be G of 0. Now what does the G function do? What does the G function do? Starts with the number 4 and subtracts whatever's in parentheses here squared. So that's 4 minus 0 squared. And what's that? 4. Yep. You get it the same answer both ways. Do you see that? All right. Now, can I clear this yet? All right. All right, to clear? You're going to see how they do it, okay? They start with the composition of F with G. That's what we had here, is defined to be F of G of X. And you plug in the innermost function first. G of X is 4 minus X squared, so that's F of 4 minus X squared. But then what does the F function tell you to do? It takes whatever's in the parentheses and adds 2 to it. What's in the parentheses here? 4 minus X squared, add 2 to it, and that gives you 4 minus X squared, that's what's in the parentheses, plus 2. And that gives you minus X squared plus 6. Same thing you got. Okay, let's do the B part. Now we're going to go to a new page so it won't be in front of you. The composition of G with F would then be, by definition, G of F of X. And if you remember, the F of X was X plus 2. So it's G operating on X plus 2. But what was the G function? It started with the number 4 and subtracted what's in here squared. So that would be 4 minus X plus 2 squared. I would have put all that in pink, but they didn't. So let's do the square first. Are we getting close to out of time? Say again? 9:43. Okay, we've got 2 minutes. Let's finish this up. You square this in here, and how you did that, I didn't ask you that. Square the first, twice the product, square the last. Okay? Then you subtract that whole quantity, and that gives you the 4 minus 4 disappear and gives you minus X squared minus 4X. Note in this case, F composed with G is not equal to G composed with F. Most of the time it will not be. There are a few times it will be, and those are very special functions when that's the case. Okay, we'll get to that later. And then finally, the last part, using the result of P, plug in negative 2, and that's minus a negative 2 squared, minus 4 times negative 2, and that would be a minus 4 plus 8 is 4. Okay. Now, before you go, let me give you a few homework exercises. I can't find where this slide is, but we'll come back and do that. That's where we'll begin next time. So homework exercises here will begin in example 6. Homework exercises, do number 3 is at calcchat.com. Any of the odds 5 through 11, they're all at CalcChat. 11's at CalcView. 13 to 23, they're all at CalcChat. 13's at CalcView. 25 or 27, both at CalcChat. 25's at CalcView. 29 through 33, they're all at CalcChat. 33's at CalcView. And we'll hold off and do the domains later. So, catch you then. So we'll start with example 6, and then we'll go back and pick up this slide here. So actually, I'm going to move it back. All right, good deal.